Hello. Okay. So today we will discuss the chapter differential equation. So first of all, we will see that what is a differential equation. What is a differential equation? A differential equation is nothing but an equation involving the derivatives of dependent variable. Now, what is dependent variable? Let's consider a function, say y equals to fx. Okay, so in this function, this y is represented in the form of x. So here this y is a dependent variable and our x is the independent variable. Now if we make an equation involving the derivative of this dependent variable with respect to this independent variable, that is called our differential equation. Suppose, let's take some examples. So our example is, that's the first order derivative. See, that's an equation and it is involved first order derivative of y. So that's a differential equation. Similarly, here is a fourth order derivative plus 2d square d2 dx2 y equals to some e to the power x. This is also a differential equation. Now we will study today the mainly we will study today the order and degree of a differential equation. Of a differential equation. Differential equation. Okay. So from this subtopic in your exam there will be just one or two questions. One or two questions. It means its weightage is 1 or 2 marks from this order and degree of a differential equation, but this 1 or 2 marks can make your 99 into 100 marks. So we can't lose this easy 1 mark so easily. So we will revise this easy topic, but most of you ignore it because it is so easy and did so many mistakes in exam. So first of all, we will revise the theory of this, then we will practice some questions. Okay, so let's define order of a differential equation. Order of a differential equation. This is nothing but the highest order derivative, the highest order derivative present in the differential equation. Highest order derivative present in the differential equation. Let's consider some examples. Example number 1. Here we can see that only first order derivative is involved, so our order will be 1. In second, there is d2y dx2 plus suppose it's square plus 2 and its whole square is equals to dy dx plus d3y dx3. Here we can see a first order derivative, a second order derivative, and also a third order derivative. But what is the order? Order is the highest order derivative present in the differential equation. So in this equation the highest order is 3. So the order of this differential equation is 3. Now there is some things we have to be careful about it, that say note order of a differential equation is always a positive integer. It is clear from its definition that it is defined as the highest order derivative, so order of derivative is always a positive integer. So order of a differential equation is also a positive integer. Now the main thing, the degree of a differential equation. That's a quite tricky thing to remember. Okay, so degree of the differential equation. The degree of a differential equation is defined by the power of highest order derivative. And it's also should be a positive integer. What does it mean? It means, let's consider some examples. First example is like d2y dx2 plus 2 dy dx plus 3y is equals to 0. This is clearly a differential equation. If I ask you about the order of this, you can clearly see that here the second order derivative is the highest order of a derivative, so our order is 2. Now I am asking you about the degree of this differential equation. So first of all, to get the degree, we have to see the highest order derivative. What is that? That is 2, and its integral power. What is it integral power? It's 1. So our degree is 1. Let's consider another example. Suppose here d3y dx3 1 3/2 is equals to dy dx. Now if I ask you about the order of this differential equation, you can clearly see that the highest order derivative is present here is 3. So our order is clearly the 3. But what is the degree of this differential equation? Many of you can say that degree is 3/2, as I am already defined that it is the highest power of highest order derivative. So if you expand it, the highest order derivative's power will be 3/2. So you can easily say that degree is 3/2. But it's not true. You can read the second line I wrote that it's also should be a positive integer, not a fraction like this. So what should I do? We should radical free. We should make it radical free. How? We will square the both sides. By squaring the both sides, we can easily remove the radicals. dy dx whole square. Now if you expand it, you will get a term like so. Our degree will be not 3 by 2, it must be 3. So if there is a point to write, note number 2, that whenever you see a differential equation, wait a second, whenever you see a differential equation having radicals, so what are the radicals? Like square root, cube roots, fourth root, and so on, sorry, and so on. You have to make it radical free at first to get the degree. Radical free make it radical free to get the degree. Also the degree, there's a note number 2 and there is note number 3, that degree is always defined, degree is always defined, sorry, degree is always defined, sorry, defined of a differential equation which is a polynomial, of derivatives. Now what does it mean? We will discuss by it an example. Let's move to the next page. Okay, so let's take an example. A polynomial of differential derivatives like this. If I write d2 dx2 whole square plus 2x dy dx plus 3y is equals to 0. Here you can see that it is a polynomial form, like of derivatives. Like I can imagine it as a polynomial of this y squared. Let's consider another alphabet, say z square plus 2 something z plus 3 is equals to 0. So it is a polynomial of derivatives. So I can easily define the degree, that order is 2 and degree is also 2, the power of highest order derivative. But if we get an equation of the form d2 dy x2, here the order is 2 plus sine of dy dx, that's not a polynomial because it is involved, it involves a trigonometric function, so that's not a polynomial. Here you can say that order is 2 but degree is not defined because it's not a polynomial of derivatives. So here we have to consider three things: that what is degree? Degree is the power of highest order derivative. Second, degree must be an positive integer. If we are getting radicals, then we have to make the equation first radical free, then we will get the degree. And third, degree is defined only on the differential equations which are polynomials of derivatives. Okay, so that's much of the theory. We will move to the questions now. Some previous year questions. So the first question is, from this subtopic you will get an MCQ. So that's your differential equation minus sine d2y dx2 is equals to 5. Now it is asked that what is the order and degree of this differential equation. Now it is clear that order is the highest order derivative, so here the fourth order derivative is the highest, so order is 4. Now you can see that this differential equation is not a polynomial of derivatives. It involves an trigonometric function sin e, so the degree is not defined. Move to the second question. The third order derivative d3y dx3 plus x dx dy dy dx whole to the power 5 equals to 4 log of d4y divided by dx4. Now from this same question, what is order and what is the degree? So here the highest order derivative is 4, so order is 4. But for the degree, the differential equation must be a polynomial of derivatives, but here logarithm function is involved, you can see, so degree is not defined. Moving to the next question, question number 3. Here the same question arises, that what is order? Order is 2, as the highest order derivative is 2. And what is degree? So many of you in the hurry, you will tick the answer 2 order and 2 degree, but you have to read the question paper carefully, and you can see that this is not a polynomial of derivatives. It involves a trigonometric function sine, so here also the degree is not defined. Now question number 4. One plus 3 dy dx whole square equals to 4 d3y dx3. So here what is the order? Order is 3, the highest order derivative. But what is the degree? Here the degree is defined. The first question where we get degree of our differential equation. Here you can see the power of this. First of all, this is a polynomial of derivatives. If you expand it, you will get a polynomial, and also it is radical free, so we can easily define the degree, which is the power of the highest order derivative. So here the highest order derivative is 3 and its power is 1, so degree is 1. Question number 5. dy dx2 sine y plus dy dx whole cube cos y equals to root y. Now it is asked that what is the product of order and degree of this equation. Now if you see in this equation, the order is 2. Now you can say that it involves trigonometric functions of sine and cos, so degree is not defined, but here the trigonometric function is of the dependent variables. If the trigonometric functions are with independent variables, so that will be considered as a radical, but as this equation involves the trigonometric functions of uh, dependent variables, so we do not consider them as a problem. So here the order is 2 and degree is 1. So our product of the order and degree will be 2. That's the answer. Question number 6. That is sin x plus cos dy dx equals to y square. Here, what is the order and degree? Order and degree. Here order is 1, clear, but degree is not defined as it is not a polynomial of derivatives. So degree is not defined. Question number 7. That's an interesting question, that it is given that ddx of dy dx whole to the power 4 is equals to 0 and m is the order and n is the degree. Then what is the value of m plus n? Now you can solve it in two ways. You can integrate it or you can just differentiate it dy this ddx, or you can integrate it. So we will do it by differentiate. If we differentiate it, we will get first let's consider is like this kind of differentiation, x to the power n. It gives us n x to the power n minus 1. So we will get 4 dy dx3. Then we have to differentiate this dy dx2 as it is a function of dependent variable. So we will get d2y dx2 is equals to 0. So here the order is 2 as the highest order derivative is 2 and degree is 1, not 3. 3 is the power of the first order derivative, but we have to consider the power of highest order derivative. So m plus n is 2 plus 1 is equals to 3. Now question number 8. The degree of this differential equation 1 dy dx2 dy dx whole square whole to the power 3 by 2 equals to d2y dx2. Now you can see this equation is not radical free, so we have to make it radical free. How? We will do it by squaring the both sides. So after squaring the both sides, I will get 1 plus dy dx whole square 3 d2 y dx2 whole square. So here the order is 2 as the highest order derivative is 2, and the power of the highest order derivative is also 2, so our degree is defined as 2. Question number 9. Here, find the degree of this differential equation. Here we can clearly see that this is a first order, so order is will be 1, and what is the power of this highest order derivative? That is 2. So degree is 2. Now question number 10. What is the question number 10? Let's okay, find the order and degree of this differential equation. X square d2y dx2 equals to 1 plus dy dx2 whole to the power 4. Now you can easily see that in this given equation it is a polynomial, it is radical free, so the degree is easily defined. The order of this differential equation is 2 as the highest order derivative is here present is 2, so order is 2. And what is the degree of this differential equation? Degree is the power of highest order derivative, that is 1. Now question number 11, that is x cube d2y dx2 whole square plus x that's quite easy one. What is the order? 2, and degree is also 2. Next question, d2y dx2 2x square here the order is clearly 2, but it is not a polynomial of derivatives, so degree is not defined, and it involves a logarithm function. Degree is not defined. Question number 13. Four plus 3x dx2 is equals to 0. Here it is a polynomial, so order is 2 as the highest order derivative is present is 2. And what is degree? Degree is 1. Next question. Question number 14. X d4y dx4 whole cube plus y dy dx whole to the power 4 plus x cube. Then it is asked that what is the degree of this differential equation. You can clearly see that the order of this differential equation is 4 and the degree is the power of highest order derivative, that is 3. Question number 15. Three y equals to 0. Here what is the order? Here order is 2 as the highest order derivative. And what is degree? Degree is 1. Question number 16. Here asks that write the sum of order and degree of differential equation. So what is our given differential equation? Our given differential equation is d dx dy dx equals to 5. Now differentiate this side. Here the order is 2 and degree is 1. Now the question number 17. Find the order and degree of this equation. Cube root of dy dx plus 1 plus x equals to 0. So it is our given equation. So we have to find the degree and order of this. Now you can see that it's not radical free. It involves a cube root here. So we have to make it radical free at first, then we will see degree is defined or not. So dy dx plus, how can we make it radical free? Let's move this into the right hand side. As it is given as cube root, so we will cube the both sides. Now cubing the both side, it will give d2y dx2 plus 1 plus x whole cube equals to minus dy dx. Now it is clear that our order is nothing but 2, that the highest order derivative, but our degree is 3. If we expand this, we will get the highest order derivative 2 and its power as 3. So our degree is 3. So the sum of order and degree will be 2 plus 3 is 5. So that's all. We practice so many questions from this topic. It's an easy one, but many of you ignores it and then attempts mistakes in exam, and you lost your valuable 1 mark. Now the next question from this topic is, wait a second, next some questions. Let our given equation be d2u by dx2 whole square plus dy dx is equals to x sin dy dx. You can see that order is 2 clearly, but degree is not defined as it is not a polynomial of derivatives. It involves a trigonometric function. So degree is not defined. Next, you can see in each year you will get an MCQ from this sum and degree. That's from paper 2023. What will be the value? It will give us 6 dy dx, 5 d2y dx2 equals to 0. Here our order, sum of order and degree, sorry, the question will be order is 2, degree is 1. Now another last note of this class. So in the competitive exam, you can solve this order degree question so easily by this trick, that the order of a differential equation is equals to number of arbitrary constant in the solution. Say we can form the differential equation in two ways. Differential equation can be formed can be formed by two ways. In your syllabus there is only one way, but actually there are two ways, can be formed by two ways. What are they? Removing the arbitrary function, arbitrary constant. In your syllabus there is only one way, that removing the arbitrary constants is the only way. So let's discuss a problem on it. Suppose this is my solution. Constants. Now it is given that it will be asked that what is the order of this differential equation. Now you can see it, this equation doesn't involve any kind of derivative, so it is not a differential equation, it is a um, solution of a differential equation. We can form a differential equation from it by removing this arbitrary constant a and b, order of the differential equation. So y is given as a y dashed a e to the power x minus y e to the power x. Now it is involving a derivative, so it can be called a differential equation, but we still not able to eliminate this a and b. We should not stop differentiating this function till we are able to eliminate these two arbitrary constants. Next we will derivative again, and we will get a e to the power x. All of you know that the derivative of the exponential function is again the exponential function, and here as it is minus x, so we will get an extra -1 in multiplication. So plus b to the power b into e to the power -x. Now you can clearly see this is nothing but the y. So from this we deduced to y double dashed minus y, that is nothing but d2y dx2 minus y is equals to 0. So what does it mean? It means that this is a second order differential equation. And what are the number of arbitrary constant? A and b. So there are two arbitrary constant, and what is the order of this differential equation? That is also true. So this point is valid. So from this trick you can get easily the order of this differential equation without solving it, or without forming the differential equation. It can be also worked as vice versa, that in the question that will be asked that what is the number of arbitrary constant in your solution, so you can easily say that the number of orders is equals to number of the arbitrary constant. Next question. Next question, let's consider um, y equals to a x plus b x square plus bx plus c. Now you can see that here three arbitrary constants are there. So what is the order of this differential equation? That is also 3. Now let's see it's true or not. So first, after the first differentiation, first order derivative, we are getting 2ax plus b. As the derivative of a constant is 0, so c will be removed. Again differentiating it, we will get equals to 2a plus that b will be 0 derivative. Then differentiating this, where d3y dx3, that will be also 0. So you can see we got from the solution the differential equation by removing all the arbitrary constants a, b and c, and the order of this is equals to the number of arbitrary constant is equals to 3. So in today's class we discussed two topics: the order and degree of a differential equation, and the formation of a differential equation by removing all the arbitrary constants.